Nearly 14 billion years ago, our universe began with the Big Bang. In a single instant, all the space, time, matter, and energy that would ever exist came into being. In the first fractions of a second, the universe was unimaginably hot and dense, a seething soup of particles and radiation. As it expanded, it cooled, allowing the first simple elements, hydrogen and helium, to form. For hundreds of millions of years, the cosmos was dark and empty of stars, filled only with giant clouds of these light gases. But gravity was at work, slowly pulling gas into dense regions. Over time, the first stars ignited, bringing light to the universe. Inside their fiery cores, heavier elements like carbon, oxygen, silicon, and iron were forged. When these early stars died in violent supernova explosions, they scattered these elements across space. This cosmic recycling process created the raw ingredients for planets, moons, and eventually life itself. In a very real sense, every atom in your body was born in the heart of a star. Around 4.6 billion years ago, in a quiet arm of the Milky Way galaxy, one of these giant clouds of gas and dust began to collapse under its own gravity. At the center of this collapse, pressure and temperature rose until nuclear fusion ignited. Our sun was born. Surrounding the young star was a swirling, rotating disk of leftover material. This protoplanetary disk stretched for billions of kilometers and was rich in hydrogen, helium, dust grains, and frozen molecules. Within this disk, gravity and motion began to sculpt the planets of our solar system. Tiny grains of dust stuck together through electrostatic forces, forming larger clumps. Over thousands of years, these clumps grew into kilometer-sized bodies called planetesimals. Collisions were frequent and often violent. Some bodies shattered into fragments, while others survived and grew larger. Through countless impacts, gravity helped merge these planetesimals into embryonic planets called protoplanets. The solar system was a dangerous place, chaotic, fiery, and violent. Asteroids whirled around. Comets crashed into young worlds, and everything was reshaped by constant impacts. One of these protoplanets, orbiting at just the right distance from the Sun, began to dominate its region of space. Over tens of millions of years, it accumulated more and more material, growing larger with each impact. This was the early Earth, a young molten world still forming out of cosmic dust and collisions. At this stage, Earth looked nothing like the blue and green planet we know today. Its surface was a glowing ocean of magma. Volcanoes erupted endlessly, releasing gases into a primitive atmosphere. Asteroids rained down from space, delivering not only destruction but also vital materials such as water and organic molecules. The Earth was being bombarded into existence. Scientists believe this chaotic period lasted for hundreds of millions of years. During this time, our planet's core formed as heavy metals like iron and nickel sank to the center, while lighter materials floated upward to form the crust. The early Earth was layered, molten, and constantly reshaped by catastrophic impacts. One such impact, with a Mars-sized body we now call Theia, would change the planet forever. But before we reach that dramatic moment, it is important to recognize that everything we see today, our oceans, continents, atmosphere, and even the possibility of life, was seeded during this violent and fiery chapter in Earth's story. The Earth was still young, unstable, and hostile, yet within its molten seas and chaotic skies, the foundation for the future was being laid. The sun shone brightly overhead, stronger and hotter than today, fueling winds and storms that tore across the planet. It was a world of extremes, and yet it was also the beginning of something remarkable. The birth of a planet that would one day support life. This is how Earth's story began, from the collapse of a giant cosmic cloud, to the ignition of our sun, to the violent formation of a molten, unstable world. From chaos, order was slowly emerging. From destruction, creation was taking place. This was the dawn of our home. After hundreds of millions of years of growth and constant bombardment, the young Earth experienced one of the most dramatic events in its history. A Mars-sized protoplanet, known as Theia, collided with the Earth in a cataclysmic impact. The collision was so immense that it melted large portions of the planet, crust and ejected massive amounts of debris into orbit around Earth. Over time, this debris coalesced to form the Moon, a celestial companion that would forever influence the Earth's rotation, tides, and even climate. The Moon was born from fire and destruction, a reminder that the formation of worlds is not a gentle process, but a violent and transformative one. The aftermath of the impact left the Earth largely molten, with a surface covered by magma oceans and a thick, turbulent atmosphere. Gases released from volcanic activity and from the impact itself created the first primitive atmosphere, composed primarily of water vapor, carbon dioxide, nitrogen, and traces of other gases. This early atmosphere was unlike the one we breathe today. It was harsh, dense, and constantly changing. Yet it laid the groundwork for the processes that would eventually allow life to emerge. As the Earth continued to cool, heavy elements sank to the core, while lighter silicate minerals formed the crust. Vast volcanic eruptions released more gases, while water vapor condensed to form the earliest bodies of liquid water. It is believed that comets and asteroids also contributed additional water, bombarding the planet with icy material that added to the emerging oceans. Slowly, over tens of millions of years, the Earth transformed from a fiery, molten world into one with a cooler, more stable crust and vast expanses of water. These first oceans were acidic and rich in dissolved minerals, creating a chemically diverse environment that would later become crucial for the origin of life. The young Earth was still being reshaped by frequent impacts, earthquakes, and volcanic activity. Yet these violent processes also created mountain ranges, ocean basins, and the first continents. The crust, though still unstable, began to organize into tectonic plates, slowly drifting and colliding to form larger landmasses. This movement recycled elements, redistributed heat, and created the dynamic surface we recognize today. The combination of water, atmosphere, and a slowly solidifying crust set the stage for a unique chemical environment capable of sustaining future life forms. During this time, the Earth's rotation and tilt were also influenced by the Moon. The tides caused by the Moon's gravity stirred the oceans, mixing water and nutrients in ways that would prove essential millions of years later. The Moon's stabilizing effect on Earth's tilt created more consistent seasons, which in turn influenced the climate patterns and geological cycles of the planet. Without this early companion, the Earth's environment might have been far more chaotic and less hospitable for life as we know it. The Earth had survived the chaos of collisions, magma oceans, and bombardments to form a planet capable of supporting complex processes. Its surface was still young, still forming, but oceans began to cover the crust, and the first signs of a stable environment emerged. From the fire and violence of its creation, the Earth was gradually becoming a world of water, land, and atmosphere, a world ready to host the most remarkable phenomenon in the universe: life. After the Earth had cooled enough for oceans to form, the surface began to stabilize, allowing the first continents to emerge. These early land masses were small, fragmented, and constantly reshaped by volcanic activity and tectonic movements. Magma from the interior of the planet pushed through the crust, creating the first volcanic islands and continental formations. Over time, collisions and mergers of these fragments gradually produced larger continents. This early continental crust was chemically different from the mantle, enriched with lighter elements that floated on the denser underlying rock. The formation of continents created environments for chemical reactions to occur, laying the foundation for the first complex molecules necessary for life. The Earth's atmosphere was also evolving. Initially dominated by water vapor, carbon dioxide, nitrogen, and small amounts of other gases, it gradually began to stabilize. Volcanic eruptions released sulfur, methane, and ammonia, adding complexity to the chemical mix. The first clouds condensed, rain fell, and the water cycle began to shape the planet. Weather patterns emerged. Erosion wore down mountains, and rivers carried minerals from the continents to the oceans. These processes helped create chemically diverse environments that were essential for the emergence of life. The atmosphere at this stage had no oxygen. It was a harsh environment, but it contained all the ingredients needed for organic chemistry to flourish. Around 3.8 to 4 billion years ago, the first signs of life began to appear. Simple single-celled organisms formed in the oceans, likely around hydrothermal vents or shallow pools rich in minerals. These early life forms, known as prokaryotes, were microscopic and simple, but they represented a monumental step in Earth's history. They began to harness chemical energy from their surroundings, using basic processes to survive, grow, and replicate. The oceans, teeming with nutrients delivered by rivers and volcanic activity, became a cradle for these tiny pioneers. Over millions of years, they adapted to their changing environment, forming communities that would eventually lead to more complex life. The interactions between the first life forms and the environment started to alter the planet in subtle ways. Some microorganisms began producing small amounts of oxygen through primitive photosynthesis, slowly changing the chemical composition of the oceans and atmosphere. These tiny biological processes would, over billions of years, lead to the eventual oxygenation of the atmosphere, making Earth suitable for more advanced life forms. The Earth, once a chaotic, molten world, was gradually becoming a living planet, where geology and biology began to influence each other in an intricate dance. This period also saw the stabilization of tectonic activity. Continents moved slowly but steadily, colliding and merging to form larger land masses. These movements created mountain ranges, deep ocean basins, and volcanic chains, constantly recycling material and heat from the Earth's interior. The dynamic interplay between continents, oceans, and atmosphere created a planet capable of sustaining life over long geological timescales. By the end of this era, the Earth had transformed from a young, fiery planet into a complex, active world, primed for the continued evolution of life. The combination of water, minerals, stable continents, and primitive life forms marked a turning point in Earth's history. From molten chaos to the first hints of life, the stage was set for an incredible journey that would continue over billions of years, ultimately giving rise to the diverse and vibrant planet we inhabit today. As Earth's early life forms continued to thrive in the oceans, they began to transform the planet on a global scale. Around 2.4 billion years ago, the first significant amounts of oxygen were released into the atmosphere in what scientists call the Great Oxidation Event. Tiny photosynthetic microorganisms, similar to modern cyanobacteria, captured sunlight and converted carbon dioxide and water into oxygen and sugar. This process gradually enriched the atmosphere with oxygen, which was previously almost non-existent. The rise of oxygen was both a blessing and a challenge. While it made Earth suitable for more complex life, it also caused the extinction of many anaerobic organisms that could not survive in this new, oxygen-rich environment. This marked a turning point in Earth's history, as the planet transitioned from a chemically simple world to one capable of supporting diverse life forms. At the same time, the movement of tectonic plates continued to shape the continents. Smaller land masses collided and merged, forming larger supercontinents such as Columbia, Rodinia, and later Pangaea. These massive land formations altered ocean currents, climate patterns, and even the distribution of life. The shifting continents created mountain ranges, valleys, and deep ocean basins, constantly recycling rocks and minerals. Volcanic activity remained intense, releasing gases that influenced the atmosphere and oceans, while erosion and sedimentation created fertile areas where early life could thrive. This dynamic geological activity laid the foundation for the complex ecosystems that would eventually emerge. Life in the oceans also grew increasingly diverse. Single-celled organisms began to form colonies, some developing specialized functions. Simple multicellular life appeared, setting the stage for the later explosion of biodiversity. Chemical interactions between life forms and their environment created feedback loops that further stabilized Earth's climate and atmosphere. The interplay of geology, chemistry, and biology began to define the planet as a self-regulating system, a concept that modern scientists describe as the Gaia hypothesis. The Earth was no longer a passive backdrop, but an active participant in shaping the evolution of life. The appearance of oxygen also enabled the development of aerobic respiration, a more efficient way for organisms to produce energy. With greater energy availability, cells could grow larger, develop more complex structures, and eventually evolve into animals. Stromatolites, microbial mats that thrived in shallow waters, became common and left fossil evidence that helped scientists understand early life. The Earth's oceans became nurseries of evolution, where life experimented with new forms, survival strategies, and adaptations. The interplay of environmental change and biological innovation would continue for billions of years, guiding the planet toward greater complexity. By around 600 million years ago, the first signs of multicellular organisms with specialized tissues appeared. These creatures were small, soft-bodied, and simple, but they represented a monumental leap in the history of life. Combined with the geological changes driven by moving continents, rising oxygen levels, and changing climate, Earth had become a dynamic, interconnected system. The foundation for the vast diversity of life that would follow, from the Cambrian explosion to the plants, animals, and humans of today, was now securely in place. Earth's journey from a molten, hostile world to a planet capable of sustaining complex life demonstrates the remarkable interplay of cosmic, geological, and biological forces, each stage built upon the last, creating conditions that would allow life not just to survive, but to flourish and evolve into forms that could shape the planet itself. This story is still unfolding, and our understanding of it continues to grow with every new discovery. After millions of years of chemical evolution, tectonic activity, and the rise of oxygen, Earth's oceans became a cradle for increasingly complex life forms. Around 540 million years ago, the Cambrian explosion marked a period of rapid diversification. Multicellular organisms with specialized tissues and organs evolved, developing shells, skeletons, and complex body plans. Predation, competition, and environmental pressures drove rapid innovation, producing the first recognizable animals such as trilobites, early arthropods, and primitive mollusks. The oceans teemed with life, forming complex ecosystems and food webs that set the stage for life to expand beyond the water. By around 400 million years ago, some organisms began to venture onto land. Simple plants and fungi colonized the continents, followed by early amphibians and insects. The development of land-dwelling life required adaptations such as lungs, limbs, and protective skin, allowing these pioneers to survive in a harsh and changing environment. The interaction between land, air, and water continued to shape the planet, creating rivers, forests, and soils that further supported life. These early terrestrial ecosystems laid the foundation for the incredible biodiversity we see on Earth today. Throughout Earth's long history, the planet has been a dynamic and interconnected system. Geological forces like volcanism, plate tectonics, and erosion constantly reshaped the landscape, while biological innovations transformed the atmosphere, oceans, and climate. Life and the planet evolved together, influencing and responding to each other in a continuous feedback loop. From the molten, chaotic early Earth to the rise of complex organisms and thriving ecosystems, the story of our planet is one of resilience, transformation, and incredible diversity. Today, as we look at Earth from space, we see a vibrant planet teeming with life, oceans that sparkle under the sun, and continents shaped by billions of years of geological activity. Every organism, from the tiniest microbe to the largest mammal, owes its existence to the long and extraordinary journey that began with dust and gas swirling around a young star. Understanding how Earth formed helps us appreciate the delicate balance and interconnectedness that make life possible, and reminds us of the preciousness of our planet. Thank you for watching. If you enjoyed this journey through Earth's incredible history, don't forget to like, comment, and subscribe. Make sure to hit the notification bell so you never miss a new video. Share this with your friends and family, and keep exploring the amazing story of our planet. The Earth has a story billions of years in the making, and there is still so much more to discover. Stay curious, and see you in the next adventure.